The seventh problem. A circular disc of mass 49 kg and radius 50 cm is mounted axially and made to rotate. Calculate its rotational kinetic energy when revolving at 120 rpm, 120 revolutions per minute. I repeat, a circular disc of mass 49 kg and radius 50 cm is mounted axially and made to rotate. Calculate its rotational kinetic energy when revolving at 120 revolutions per minute. So what is the rotational kinetic energy? It is a sum of the translational as well as the what is the formula for the rotational kinetic energy? That is equal to half I omega square. For a circular disc of mass m and radius r, the moment of inertia about a perpendicular axis. Here the axis, which is the disc is made to rotate. That is the perpendicular axis passing through the center. So what is the moment of inertia? The moment of inertia I is equal to mr square by 2. Okay. So we can substitute this value, this expression in the formula. So half into mr square by 2 omega square. So that's equal to 1 by 4 mr square omega square. Okay. Now let us check what are the values given. Here the mass is given, that is capital M is equal to 49 kg and the radius capital R is equal to 50 cm, that is equal to 0.5 meter, and we are given the angular velocity in terms of 120 revolutions per minute. Okay, so omega is equal to, we have to convert into revolutions, 2 pi into revolutions per second, that is 2 pi f, that is we have to substitute, that is 2 pi into, here we are given the revolutions per minute, that we convert into revolutions per second, that is 120 divided by 60. Okay. So 120 divided by 60, that is here 2, that is omega is equal to 4 pi radian per second. Now we have all the values. We can substitute 1 by 4, 40 into 49, radius 0.5 whole square into omega, that is 4 pi whole square. So you can do the calculation. So the answer will be 483.1 joule. Okay. Now the next problem. A uniform disk is rolling on a horizontal surface at a speed 3 revolutions per second. The radius of the disk is 10 cm and the mass is 1.2 kg. Calculate its rotational kinetic energy. Here also we are asked to find the rotational kinetic energy that we have done in the previous problem. Okay, so we can directly write the expression for the rotational kinetic energy, that is E is equal to 1 by 4 mr square omega square. So E is equal to rotational kinetic energy is equal to 1 by 4 m r square omega square. Okay, let us take here the mass m is 1.2 kilogram and the radius is 10 centimeter, that is equal to 0.1 meter, and here the frequency is given, the 3 revolutions per second. Now the angular velocity omega is equal to 2 pi f, that is 2 pi into 3 revolutions per second, that is equal to 6 pi radian per second. Okay, now we have all the values. Let us substitute 1 by 4 is equal to 1 by 4 into 1.2 to 0.1 to 6 pi whole square. Now you can do the calculation. So the answer is 1.06 joule. 1.06 joule. Okay. Now the next problem. 5 masses, 2 kilogram, 5 kilogram, 1 kilogram, 5 kilogram and 2 kilogram are placed on a massless rod as shown in the figure. The distance between consecutive masses is 0.2 meter. Find the moment of inertia about the perpendicular axis passing through the 1 kilogram mass. 5 masses, 2 kilogram, 5 kilogram, 1 kilogram, 5 kilogram and 2 kilogram are placed on a massless rod as shown in the figure. The distance between the consecutive masses is 0.2 meter. Find the moment of inertia about the perpendicular axis passing through the 1 kilogram mass. So you can see in the figure that here the 5 masses are placed on a massless rod. Okay, and the distance between two consecutive masses is 0.2 meter. Okay, so we have to find the moment of inertia about the perpendicular axis that is passing through the 1 kilogram mass. Here we have the 4 masses are distributed around this perpendicular axis. Okay, now we have to find the moment of inertia of the each particle and then find the total moment of inertia. Okay, so the moment of inertia, so let us write this is the mass m1, this is m2 and this is m3 and this is m4. Okay, so m1, the first mass 2 kilogram is m1, second mass 5 kilogram is m2, and on the right side the 5 kilogram mass is m3 and the 2 kilogram, last 2 kilogram mass is the m4. So the moment of inertia of the body of this system of particles is the moment of inertia of the sum of the moment of inertia of the individual particles, that is sigma mi ri square, that is m1 r1 square plus m2 r2 square plus m3 r3 square plus m4 r4 square. Okay, now let us substitute the values. m1, that is 2 kilogram, into what is the distance of that 2 kilogram mass from the axis, that is 0.2 plus 0.2, that is 0.4 meter. So 0.4 square plus m2, that is 5 kilogram, into the distance from that mass from distance of that mass from the axis, that is 0.2 kilogram. Sorry, 0.2 meter, that is 0.2 square, plus similarly again on the right side 5 kilogram into again 0.2 square plus 2 kilogram into 0.4 square. So you can substitute and then you then complete the calculation. The calculation, that is 2 into 0.16 plus 5 into 0.04 plus again 5 into 0.04 plus 2 into 0.16. So the answer is 1.04 kilogram meter square. 1.04 kilogram meter square. Okay. Now the next problem. The moment of inertia of a wheel about an axis of rotation is 3.1 kilogram meter square, and its kinetic energy of rotation is 600 joule. What is its angular velocity? The moment of inertia of a wheel about an axis of rotation is 3.1 kilogram meter square, and its kinetic energy of rotation is 600 joule. What is its angular velocity? So how can we do this problem? Here we have the kinetic energy of rotation is given. So the rotational kinetic energy A is equal to, what is the formula? In the case of a wheel, anyway, in the case of a wheel, the rotational kinetic energy, that is half I omega square. Half I omega square. Okay. From that we have to find out the value of angular velocity. So omega is equal to square root of 2e divided by I. Then what are the values given? Here the kinetic energy of rotation E is given 600 joule, and the moment of inertia is also given, that is I is equal to 3.1 kilogram meter square. So we can substitute these values, that is omega is equal to square root of 2 times 600 divided by 3.1. So the answer is 19.67. What is the unit? Radian per second. 19.67 radian per second. Okay. Next, a constant torque acting on a disc changes its angular momentum from L to 4 times of L in 4 seconds. Find the torque. A constant torque acting on a disc changes its angular momentum from L to 4L in 4 seconds. Find the torque. What is the relation between torque and angular momentum? The torque tau is equal to the change in angular momentum divided by the time, the rate of change of angular momentum. Here, what is L1? L1 is equal to, we can express by capital L. What is L2? That is 4 times of capital L. What is the time? The time is 4 seconds. So the torque tau is equal to 4L minus L divided by 4. That is tau is equal to 3 by 4 L. That is the answer. Okay. Now the next problem. The angular momentum of a body changes from 10 joule second to 50 joule seconds in 2 seconds by the application of a torque. What is the torque applied? The angular momentum of a body changes from 10 joule second to 50 joule second in 2 seconds by the application of a torque. What is the torque applied? Here also we can use the torque and the angular momentum relation, that is tau is equal to the change in angular momentum divided by the time. Here what is the initial angular momentum? L1 is equal to 10 joule second. Final angular momentum L2 is equal to 50 joule second. This change happen in time t is equal to 2 seconds. So the torque tau is equal to final angular momentum 50 minus initial angular momentum 10 divided by the time 2 seconds. Okay. So what is the value? You can do the calculation. That is 20 Newton meter. That is the required torque. Okay. Tau is equal to 20 Newton meter. Okay, thank you.